Okay, so let's talk about passwords. We have James Crifasi here today, who's the CTO of RedZone. And we had a couple interesting happenings this past week that we thought would be good to share with the audience. And one of them is passwords, the creation of adequate passwords for an environment. So do you think that the old ways of creating passwords are potentially might be done?
So we've been called in for quite a few issues that were classified as hacks where in reality someone lost their password. If we look at...
Lost or got hacked?
Lost their password or someone guessed their password. No indications of someone actually doing the effort of hacking. For all we know, they wrote it down on a Post-it and lost it. But if we look at that, and then recently we had a security incident where we were allowed to take about 1,500 different accounts and crack them to answer the question of how good are the passwords. So we took these 1,500 accounts, and what we're able to find is that most of what IT trains users on and kind of the IT passwords themselves that were thought to be strong were cracked very, very quickly. And this became important because a lot of the calls that we get about hacks in reality are really just someone logging in as the user using their password. So if we take this as an example, out of 1,500 accounts, we were surprised to figure out that on a really, really low class, slow machine that was not good at all, about 250 of the 1,500 were cracked instantly. So that means
250?
250. So that's microseconds. So not fast, but instantly. Past that, if we look at passwords that were cracked in within 20 seconds, it was almost about 600 of the 1,500 could be cracked in 20 seconds. And then almost 900 of them could be cracked in 5 hours. So if we look at this in terms of a malware, that means a simple malware running on a relatively low-class end-user PC can crack the majority of passwords in an environment, and no one will even notice that the cracker's running because it doesn't need much CPU or RAM, and no one has to exfiltrate data. What we also found is, like in most environments, the complexity requirements were on, and a lot of the passwords were 11 to 15 digits long.
The complexity requirements are on.
So that's the, you need to have 3 of the 4 uppercase, lowercase, number, special symbol, your standard pieces there. But they were also 11 to 15 digits. It's a pretty long password. And it was fun from the IT point of view to run the cracker because we found that we had some 5-digit passwords that actually outlasted the majority of the 10 to 15 character passwords. And what we realized is that how the crackers are working is a little bit different than what everyone's been trained and what we've really looked at. And so just as an example, a lot of people have been trained when you create a long word password, you sit there and you say, well, E I can replace with a 3, and A I'll replace with an @ sign, and I I'll replace with an exclamation point. And people have learned these mnemonics on the keyboard to figure out, okay, how do I remember all these annoying special characters and still have a password that I don't have to write down all the time? And what we found is anyone doing that, basically with the amount of research going into spell checkers and predictive typing and things like that, all of that's being built into the dictionary for the cracker. So all of those common replacements are actually built into the system. And we had some very, very long, complicated passwords that were found almost instantly because they were a standard replacement of characters. So we had one that, as an example, had $2 signs, 2 @ signs, an exclamation point, 4 numbers, 7 letters, and it was cracked instantly. Because even though it should be really, really long and really, really hard, when they look at it, it's actually a visual message. And as that research keeps getting done, to make predictive typing better, and as people fail to write English anymore in text messages and things like that, those are all databases that cracking systems can use. It's all basically a word dictionary that can be downloaded from Google, from your phone, from wherever, and used as a simple dictionary attack as opposed to a very hard character by character numerical crack.
How big is that dictionary, you think?
So we did some checking. I can download the Webster's Word Dictionary was 2 megs, and then the Hacker Dictionary that we were using was about 550 megs. So 250 times the size of a Webster's Dictionary, and that was just English. And of course, a lot of the crackers, you want to have variants of English and foreign languages. And there's also dictionaries that are being used now where you can get very simple downloads of movie titles, actor names, things like that. So that's interesting because people would think, well, that's not really a word, it's a phrase, but it's loaded in a dictionary. So that means even though it's 20 characters long, it's still just a word from a dictionary point of view.
Or the title of a movie.
Title of the movie, title of the book, all downloadable. You can basically pull a download of the title of every movie since, I think it's like 1912 or something like that, or some age-old number. And it's not very big because it's just a text string. You know, it's not like it's the IMDB database, although I'm given to understand IMDB will also let you download a text file of all the actor names. But it's all stuff available to programmers. It's all stuff available on the internet. And then when you run it through a cracker, it's all stuff that's actually really, really useful. You know, a very common password issue right now is winter. I think everybody loves Game of Thrones. So winter is definitely coming into all of the passwords that everybody has for sure. But really the issues that we found were habitual passwords or people having a password policy, but the password policy is based on something visual, or even worse than that is keyboard patterns. Keyboard patterns have actually been a no-no for about a decade now, but people are still using them. So it's kind of where you start from Z and you go up the keyboard, and then you start at 2 and you come down the keyboard. And people think, well, that's got a lot of funky symbols and stuff in there. In reality, anything on a keyboard that's simple to type, that's also in the dictionary.
What's the visual one that you're referring to? Are you talking about like when you pick a map, like point and click on like here's the
No, so visual being if you take the word message and you replace the A with a @ sign or a E with a 3, visually in your mind it's still the same word. But unfortunately those are patterns that are actually really easy to get into a dictionary. When you have all the developers working on that predictive typing and trying to help people write correctly, all of that can be reversed, downloaded into a very simple sheet of what are the most common things people do. And now all of a sudden you have a nice dictionary you can run as a password cracker. And so visually that's what you're really talking about is they're trying to type something that makes sense if they imagine it in their mind. And unfortunately the computer can predict that better than the people can. So it becomes pretty hard to make a good password. And actually, in this case, a lot of the IT and other developer passwords were cracked quite fast. And a lot of them were the ones that are supposed to be hard. A lot of them weren't even words. It was just a list of symbols. But people who are going to type lists of symbols will naturally have a keyboard pattern. And you think about all the research keyboard manufacturers do to figure out how expensive a spring do I need for each one of these keys, because if I can save 20 cents by having lesser used keys have a weaker spring, people have done that research. So people know what keys are most used. So from a cracking dictionary point of view, that's not even difficult math. That's using data sets that are available and a little bit of statistics and then build that into the dictionary set. So all those end up being pretty easy. And so then it comes down to what are people supposed to do for passwords? So when it was related to this incident, the interesting kind of hurdle to tackle was the issue that people were very reluctant to say, I don't want something that's harder. And so the communication break was the fact that harder wasn't helping anyway. So, because if we can crack really hard, quote unquote, hard passwords that are 15 characters long in 20 seconds or less, making it harder is not really helping. Making it more convoluted wasn't really helping. And so what we found, the ones that were working the best were phrases intermixed with the numbers or symbols. What I mean by that is whenever someone had a password where all the letters were together and they were numbers or symbols before or after it, those are actually cracked really fast because the words were all together, and it's just a question of twiddling some symbols on either side of it to be able to crack the password. So some people would have really long passwords like steak dinner 12. Well, okay, that's just a word right there with a couple of numbers, not hard to hack at all. So the ones that lasted really well were actually a lot of short words.
Like sentences strung together?
Yeah, a sentence, a phrase, a limerick, what have you, but it was sentences where the numbers were in between the words.
Okay.
So you would have to have a word and then be able to rotate characters with the number and then another word and then another number, and that became very hard. Now, mathematically speaking, any password can be cracked given enough time, and computers are getting faster, obviously, but everyone is supposed to change their password. So if you're changing your password, the amount of time people have to make use of a decent strength password is pretty finite. You don't have forever to sit there and crack something and play with it before it becomes unfeasible and you can't really do anything with it. So a string of words with numbers in between become very useful, especially if it's more than one number. Mailman 1 is not a very good password, right?
Yeah.
You just try to rotate some numbers, you're going to try 0, then you're going to try 1, and now you have the password. It's not very hard. But intermixing those short words with a couple of numbers, another short word, couple of numbers, short word, a couple of number, not very hard to remember because you can have it be part of a sentence. But strength-wise was much better than sitting there trying to replace 4 of the 10 digits in your password with @ signs and exclamation points and dollar signs. It just wasn't really effective in comparison.